So this is the Java compilation cycle. It's divided in two phases. The first one is the Java compiler or Java C command, and the other one is the Java virtual machine or JVM. The Java compiler is divided in 7 steps. That the first one is scan all the .java files and convert it into AST or abstract syntax nodes. This is basically scan all the .java file and convert all the words into token that can be processed. And in the step 2, search all the definitions in the symbol table. That it's basically just a table that has a definition for all the special tokens for words, such as, for example, float, strings, int, etc. The step 3 is to process any annotations if it's a request. Then in the step 7 is make the attributes of the syntax tree, such as name, resolution, type, etc. Then the step 5, it makes a data flow analysis. So it takes off assignment of variables or any, for example, loops. Then in the step 6, it refactors the AST to remove some trash code. Then in the final step, or in this step 7, it generates the bytecode files for the known .java.class files. And basically the bytecode means a computer object code that an interpreter, or for example the JVM, can convert it into machine binary code, so it can be read by a hardware processor, by a computer basically. And then there is the JVM, that it's the interpreter that processes the bytecode and converts it into native machine code. The first one is to basically obviously load the .class, or basically this file that is generated at the end of the compiler, and then it verifies all the bytecode, all these computer object, that in this case the bytecode cannot be read by a human, obviously, and it's just a bunch of random letters and random symbols that cannot be interpreted by a human. And in this verifies all the bytecode, or basically all the code that it's currently written out. And then the just-in-time compiler that basically just converts bytecode into machine code and then executes the native machine code. Now the switch statement. What is the switch statement? It's basically a multi-way branch statement that executes one statement from multiple conditions, as you can see in this standard syntax for Java, and in this standard flowchart. And the switch statement, it's a good alternative for the if-else statement, basically because it's more easy to write, more easy to understand, and it's more fast than the if-else. And basically how this switch works is basically that you put a switch and between parentheses you write a condition expression. You can be an integer, a float, a string, a boolean, even list or arrays. It can be basically anything. And then after you gave him the expression, it will see if in the case condition 1 it's true, okay, will be execute the statement and then break the loop. Then if not, well, if we check all the other conditions until the default, that it's basically the default, that if none of these last conditions it's true or are false all, it would run a default statement to close the switch case. And this is very recommended to use because it's very good to avoid some errors related with this statement. Now these are some an example of this switch statement, that it's, well, in this case I put an age and would take that age as a parameter, as a conditional statement, and then it would see if it's sure that the age is 10, okay, we'll execute that you are too young. If you have 15, you're a bit young. If you have 17, would execute you have just a perfect age. And then if you have 20, well, you're too old, and you have neither of these ages, well, your age is not valid for this example of switch statement.
When it comes to object-oriented programming, we use classes, objects, methods, and variables to create objects and manipulate their different parts to create an outcome. This may seem complicated at first, but first we need to break it down and know what each of the concepts mean. First, you create a class by using the command public class, and it creates kind of a category for these objects. So if you create the class car, all the objects inside need to be cars. They can't be like motorcycles or any other kind of vehicle. Then you set as standards for these objects, like how you describe them. These are what variables do, so they store these attributes and characteristics of the cars. So when you create the objects, which are like specific entities, they have their own characteristics, their own variables. First, you have to set up a constructor, which usually uses a public and then the name of the class, and then you describe the variables that it requires. So, for example, all objects that are cars will have a color, a brand, and a set speed. So then you call car and name it new car, which has created your objects with their characteristics inside the parentheses. Finally, you start to modify the objects using the methods. They define the behaviors and actions of these objects and they make them happen. You create methods with the command void, and then inside you code like what they will do. And later you call them and they will do this action. So in this example, the methods will start, accelerate, stop, and describe the details of the car in each step. So when you start the program, these methods will execute and be modifying what the car variables are. So in this case it's the speed, and it will show what is its speed. So the variables, the methods will accelerate or stop, and that will change the speed. So in summary, object-oriented programming creates these objects which have variables and which are their characteristics. They belong to a class of similar things, and they use methods to create actions.
Different programming paradigms are different types of approaches to building solutions to a specific type of problems. In object-oriented programming, everything is represented as objects. Think of real-world things, like cars or phones. These objects have properties, or attributes, and actions, called methods. For instance, an object like a car may have attributes like color, and methods like drive or park. In object-oriented programming, we define these objects using classes, which act as blueprints. This structure makes object-oriented programming great for organizing complex programs by breaking them down into smaller pieces. Java is a great example of object-oriented programming. Here, for example, we have a class, car, which has properties such as color, red, or number of doors, 4. It can perform actions such as drive or park, which would change its state of being parked. Procedural programming is one of the oldest and most famous paradigms, where programs are reading as sequences of steps, or procedures. Here, functions are used to break down the program into smaller tasks, but there's no emphasis on objects or classes. While it's straightforward, large problems can become difficult to manage as they grow in size. Functional programming takes a different approach. It treats computation as the evolution of mathematical functions and avoids changing state or data. With this paradigm, you define what you want to do rather than how to do it. This paradigm is good at tasks like data processing, especially in large-scale systems. Object-oriented programming is excellent for modeling real-world scenarios on large applications due to its focus on objects and reuse of code through inheritance. There exist other programming paradigms, which each has its difference from the others and its own advantages and disadvantages.
The scanner is a function we can use to make an input from our keyboard and to store it in a variable. To use the scanner, we're gonna first have to import the scanner. For this, we're gonna put the following command. The following program I'm gonna create is a brief program in which we're gonna compare how to use the system.in program and the system.out, which is like the opposite because the system.in helps us to make an input, the system.out helps us to do an output through our screen. To first create your scanner, you're gonna have to put the following command. The following is the name you're gonna give to your scanner. In this case, I'm gonna use DS. Now I'm gonna use a system.out function to ask a question. Now I'm gonna use the function of the scanner to make an input. In this case, I'm gonna put an integer. So for this, we're gonna have to use the function next int. If it was a double, it would be next double. If it was a string, it's gonna be next string. But as it's an integer, next integer. With this command, we're gonna be able to put a number, a value from our keyboard. So now we're gonna compile and try out our program. First, we're gonna make our input. I'm gonna type a random number. And in this part, we can see how we use the scanner to have an input and an output.